Hello, calculus students. We're in section 10.11, finding Taylor polynomial approximations of functions. And in this problem, we have let f be a function with second derivative. So we know the second derivative of our function, and we're trying to figure out what the coefficient of x minus 8 to the fourth would be in the fourth degree Taylor polynomial for f about x equals 8. So what we basically need to think about, the Taylor polynomial at x equals 8. What do the coefficients look like? Well, they're going to look like in this case, we want the fourth degree. So we're going to look at the fourth derivative of our function, evaluated at 8. And then we're going to take that and we're going to divide by 4 factorial, which is 24. So what we want to figure out, basically, is what the fourth derivative at 8 would be. And we're going to put it on top of this ratio, and that will be my answer. So we have the second derivative already given to us as quantity 3x plus 1 to the half power. So I think we could take the third derivative. So let's find the third derivative, f triple prime. And that would be equaling to, I guess, 1/2 brought down times 3x plus 1. And then we'll subtract 1 from the power, so that becomes a negative 1/2. But then we have to remind ourselves that we have a chain rule here. So we're going to multiply by 3. So we're actually going to have a 3/2 here on the outside instead. So our third derivative is 3/2 times quantity 3x plus 1 to the negative 1/2 power. Now, we're going to take the next derivative, or our fourth derivative, and once we've done that, we're going to stick our 8 in. So my fourth derivative, I'm going to bring down my negative 1/2, and it looks like I'm going to get negative 3/4 times 3x plus 1. Subtract 1 again from the power, this time I get negative 3/2. And again, chain rule says multiply by 3. So now this actually becomes a negative 9. So I have negative 9/4, 3x plus 1 to negative 3/2 as my fourth derivative. And let's stick 8 into this. So when I stick 8 into this fourth derivative, I'm going to get a nice perfect square number, 25. So I'm going to have a 25 to the 3/2 power on the bottom, multiplied by 4. Notice I took my negative power and made it positive. And on top, it looks like I'm going to have a negative 9. So when we finish cleaning this up, let's say the square root of 25 is 5, and 5 cubed is 125. And 4 times 125 is 500. So we actually have negative 9 over 500. Now what we're going to do is, once we have our negative 9 over our 500, is we're going to replace the numerator here of this coefficient with that number. So let's put negative 9 over 500. And that 524, I guess, could mush together, and we get a negative 9 over 12,000. 24 500s, I guess, would be 12,000. And then we could reduce that down to our final answer of negative 3 over 4,000.